keyboard here. Get rid of my keyboard. So kind of the way you can look at these is if I put the point 3 comma minus 4 on there and connect it with a line to the origin.
Yep.
Now rotate that 180 degrees, and it doesn't matter whether you go clockwise or counterclockwise, you end up there. And what are the coordinates on that point?
-3, +4.
No, it's actually -4, +3.
Yeah, I forgot that it.
Well, it's tricky, and let me point out something here.
Okay.
The way to remember this, to be honest with you, I didn't remember what it was either. Okay, but the way I figured it out was I drew something that had a little more slope to it, and I put points 1 comma minus 4 on that point, and then I rotate. Excuse me, a second. Then I rotated that line about 180 degrees, and I ended up with that. And now it's perfectly clear how you have to do it.
Yeah.
Oh, you're right, actually. I made a mistake. It is -1 + 4. So when you do it, yeah, my apologies. I was doing it in my head, but that point is going to be -3 + 4. So it's all you do is change the sign of each one. But nonetheless, it's hard to figure out when the 2 points are close to where they each other. In other words, it's hard to figure out when I reflect this where that point is. Whereas when I increase the slope, like I did, now it's absolutely clear that that point cannot be 4 or -4 + 1. Whatever mistake I was making before that I might make, I can't make with this picture. So if you ever forget, remember, just steepen the slope and it'll get you back to the correct.
Okay.
Okay?
Yeah, thank you.
Yeah. These tend to be fairly easy. If you're translating it by that vector -2 comma 5, where do you think it ends up?
For the original point or the one that was rotated?
The original. All 4 of these are translations or rotations or reflections of this point.
Okay. So would it be 1 and then -9?
Add the 2 together. You got the 1 correct.
Oh, so it'd be 1 and 1, 1?
1, 1, exactly. In other words, what they're saying here is that if I start from the original point and I go left 2 and up 5, where do I end up? Well, I subtract 2 from the 3 and I add 5 to the -4.
Yeah.
Okay, and so you end up at 1, 1, but it's kind of, when you're talking vector, direction matters. And so the first part of that vector, -2, meant that I had to go to the left. The second part of the vector, +5, meant I had to go up, not down.
Okay.
Okay.
Yeah.
Reflections over the axes is fairly straightforward also. If I reflect this over the x-axis, it's going to basically be that. What are the coordinates going to be on that?
It would be
Does the x-coordinate change?
no.
That's the way to think about it. The x-coordinate has to stay the same. The y-coordinate definitely changes. What does it become?
It becomes negative.
Well, it started out negative. It started out as
So
3 comma
positive.
minus 4.
Yeah, I was looking at the wrong number. So yeah, it becomes positive.
Okay. So that's 3 comma 4. That's a reflection over the x-axis. Now let's reflect it over the y-axis. And I'll do that, this way. What's the coordinates on that point?
It would be -3, -4.
Correct. In other words, the y-coordinate does not change. When you reflect over the y-axis, the y-coordinate doesn't change. When you reflect over the x-axis, the x-coordinate doesn't change.
Okay.
Now, that question actually said reflect over the y-axis and then rotate 90 degrees, but it didn't tell us which way unless there's another word on this piece of paper that I'm not seeing.
No, it just says reflect over the x-axis, then rotate 90 degrees.
Yeah, and you can rotate counterclockwise or clockwise.
Mm-hmm.
Well, it matters, clearly. The first rotation was 180 degrees, and counterclockwise and clockwise get you to the same point. But the 90-degree rotation, I basically take this point and I rotate that line. If it's 90 degrees clockwise, I'm going to make sure that that's a right angle. And notice that it appears that I end up at -4 plus 3. In other words, when you do a 90-degree rotation, you switch the numbers and you switch the sign on the number on the left. If I do a 90 degrees clockwise rotation, if I do a 90 degrees counterclockwise rotation, then I end up there, and that, we already know, that would be a straight line. So this has to be 4 comma minus 3. Just switching the signs on both numbers. So the answer is either -4 comma 3 or 4 comma minus 3, depending on whether they meant clockwise or counterclockwise. Now, I'm not aware of any standard math. In other words, if you don't specify that it means clockwise or counterclockwise. Actually, with trig, you usually are going counterclockwise. So I'm not sure what they mean when they say rotate 90. Which way?
Yeah, I'm not sure either.
Yeah, okay. Well, let's just keep going. Yeah, no, there's no other word there. 32. All right, so 32 has a mistake in it, somewhere in those 3 points.
Yeah.
Oh, no, I get it now. Hold on. learn how to work with this. Correctly solve the problem, justify that your solution is correct. So first, the incorrect solution. -3 is less than... I think this must mean angle 3 is less than angle 2.
Yeah, I think so.
They didn't have a symbol that was an angle sign, so they used the less than sign.
Yeah, I think that's what ended up happening.
Okay. The next line. Where'd they get that line from? Well, first of all, I'm sorry. Let's go back to the first one. I got so distracted by their lack of an angle sign that I didn't notice something. Well, no, it is true. Angle 3. What's wrong with that first line?
They said that the angles are equal to each other, but
And they're not. Clearly, one is acute and one is obtuse.
yeah.
So you could say that angle 3 is less than angle 2.
Yeah.
Which is what I kept doing in my head, and that seemed okay. But that's not what they're saying. They're saying angle 3 is equal to angle 2, and clearly that's not correct. They don't fit any of the equal angles for parallel lines in a transversal. In fact, what we know is that they are supplementary.
So they would have to equal 180?
Right, if you added them together, correct. And so their step 2 isn't correct either, because that's based on angle 3 being equal to angle 2. And that's how they came up with their step 2. So once they've made the initial mistake, there's no recovering from it.
Yeah.
Okay, correctly solve the problem. Well, here, let's go over here. So let's see, we're solving for x. So how would we correctly solve for x?
Would you do 11x minus 12 plus 5x plus 48 equals 180?
Yeah, although that might not be my first line. My first line might be angle 2 plus angle 3 is equal to 180.
Okay.
That would be my first line, and then of course that's angle 2 and that's angle 3. In other words, kind of lay out your logic. And since their incorrect solution started with that line, then that's where I would correct it for the correct solution. And then of course that's, I know you know how to solve that. We can go to the next one and not spend our time on you just doing arithmetic. In terms of justifying your solution, is all you need to say is that these two angles are supplementary. Why are they supplementary? Because the two angles, that's an interesting question. The obtuse and the acute angle that are created with two parallel lines and a transversal are always supplementary.
Okay.
Now, you might have to take that slightly a step further, but I don't know. In other words, you see the angle that's vertical to 2?
Yeah.
Well, excuse me. See the angle that's the linear pair to 2? This one right here that let me point at it with my, there we go. Can you see where I'm pointing?
Yeah, I do.
See that angle? You know that angle is supplementary to 2, correct?
Yeah.
Because it's a linear pair. And we also know that angle is the same as angle 3 because they're corresponding angles. And there is a theorem regarding that.
Oh, okay.
Therefore, we can state that 3 and 2 are supplementary by substitution. So a complete two-column proof would actually have to go through that, I believe. I don't think there's a single statement that allows you to say that angle 2 plus angle 3 equals 180 unless you go through the technical proof of it. You know what I'm saying?
Yeah, I get it.
All right. Yeah, we've worked with enough proofs that you. Hmm. All right. Let's start with a kite. How many rows do we have here? We have row 1, 2, 3, 4, 5, 6. I don't know why they didn't number them. It would make it more logical and easier to talk about.
Yeah.
Is row 1 true for a kite?
Um, no.
Is row 2 true for a kite?
Um,
Here, I'll draw a kite. And when you're drawing these figures, draw them exaggerated, like this. As opposed to, that's also a kite, but I can't quite answer the questions as easily.
yeah.
If I draw the exaggerated kite, then clearly my opposite sides are not parallel, right? You can see it with an exaggerated kite. If I draw the kite on the right, well, those opposite sides do look parallel, so I can't really tell. So whenever you're doing these, draw exaggerated if you can. You'll be able to answer the questions much easier.
Okay.
Do the diagonals bisect each other?
No.
Well, that's correct.
Oh,
They do not.
they,
One does. One diagonal bisects the other. In other words, the
mhm.
longer diagonal bisects the shorter diagonal, but that's it. So the answer is no, for sure, because it indicates that they both bisect each other. Diagonals are congruent.
No.
So far we got nothing but no's. Diagonals are perpendicular.
Uh, yes.
Correct. And opposite angles are congruent.
Uh, no.
Right. This angle down here is clearly not as big as that angle there.
Yeah.
Whereas if I looked at this kite over here, even if I didn't exaggerate it a lot, just exaggerated it a little, it'd be hard for me to tell whether that angle and that angle are the same. And
Mhm.
this is a case also where these two angles are equal, but the top and bottom ones are not, which means
Yeah.
the opposite angles are not congruent. All right, let's look at an isosceles trapezoid. Here, let me draw it. When I draw these, this is what you should do also. Rather than trying to figure it out from the picture that's in your brain, draw one. And then it's really
Yeah.
much easier to answer each of these questions. Now, I
Mhm.
exaggerated this a little bit. I made it quite long.
Yeah.
Not going to be that useful, but to exaggerate it. But always exaggerate it if you can. Both
Okay.
sides of opposite side, both sets of opposite sides are parallel.
No.
Opposite sides are congruent.
No.
diagonals bisect each other?
Yes.
Doesn't
I'm not
look like
sure.
it, does it?
No.
To me, like this one is shorter than this one. So to solve
Yeah.
that, let me really exaggerate it and see if that helps. I'll exaggerate the severity of the angle. And I'll exaggerate the length a lot. And then I'll draw the diagonal.
Yeah.
Be honest with you, I don't know, but looks like they do. Do you know the answer?
I we wrote it down in our notes.
How can we tell whether it was or not? Notice that if triangle 1 is congruent to triangle 2, then they do bisect one another. Right?
Yeah.
In other words, if I can prove that that is equal to that, and this side is equal to this side, then they're bisecting one another. And notice that that is true because this angle, because the parallel lines, that angle is equal to that angle. This angle is equal to this angle. And this angle, the third angle, is equal. So we have three equal angles. That doesn't prove congruency, though. That proves similarity. How can we prove that triangle is congruent? I was working with the wrong two triangles. Notice that if I work with these two triangles, triangle 1 and triangle 2, if I can prove those two are congruent, then it proves that side's equal to that side, and that side's equal to that side, and they would bisect one another. And I can prove this because I know that side is equal to that side because it's an isosceles trapezoid. So if I get three angles on one side, they're congruent. That's the same as angle, side, angle.
Okay.
Once I've proved they're congruent, then I know that they bisect one another. And that's really what you have to do. This is one where I'm not sure you can really see it visually. Although it certainly appears that they do. I guess the moral is that if it appears they do, then assume that they do. Unless you can draw it in such a way where it's clear that they do not, then, you know, when we drew a kite, it was pretty clear that they did not bisect one another.
Yeah.
Are the diagonals congruent for an isosceles trapezoid?
No.
Yes, they are. In other words, both diagonals are equal to one another in length.
Oh.
See why? Only because it's an isosceles trapezoid.
Yeah.
In other words, I've proven with the previous thing that that's equal to that. And if that's equal to that, that doesn't prove that they're equal to one another. I have to look at this slightly differently. I can't look at it like that. I have to look at it as there's two triangles here. One of them is this one. The other one is this one. You see the two triangles?
Yeah.
Triangle 1, triangle 2. Well, if I can prove those two triangles are congruent, then I know that the diagonals are equal to one, or congruent to one another. And I can definitely do that because I know that angle is equal to that angle. Hold on a minute. Excuse me. That angle is equal to that angle. No, it isn't. Hold on. That side's equal to that side. The middle side is equal to itself. The top is not equal to the bottom. Gosh, Connor, I hate to run, but I got half-hour appointments stacked up until 9 o'clock tonight. So
All right.
I have a 7:30 that's waiting, so I
Okay.
can finish this. But the diagonals are definitely equal to one another. I just got caught in the middle of proving those two triangles were congruent, and I got to run.
All right. Well, thank you for your help.
You're welcome, and I will talk to you at your next session.
All right. Sounds good. Thank you.
Bye-bye.
Bye.